In this lesson, we're going to learn about linear and nonlinear functions. So if we have a problem like this that says determine if the function in the table is linear or nonlinear, and we have a table, these are the x values and these are the y values. Okay, so we just need to figure out if it's a linear function. So understand the terms linear and nonlinear. A linear function has a constant rate of change. So the rate of change between these 2 points and these 2 points would be the same as for this point and these 2 points, okay? So the rate of change from here to here is supposed to be the same as here to here. That's what a linear function would show. A nonlinear function does not. So the rate of change going from these 2 points to these 2 points and then from these 2 points to these 2 points would not be the same. Okay? That's all it means. Let me just show you with the numbers. So a function has a constant rate of change if its rate of change is the same between any 2 points. So if we look at that in terms of an equation, it would look like this. So these are the two y numbers and these are the two x numbers. So calculate this for any 2 points. So let's do that. So pick any 2 points on the table and calculate the rate of change between them. So we're going to calculate this, okay? For the 2 points, choose both the x and y for each as shown. So let's see what it's going to tell us next. So we're going to pick these. These are the ones we're going to pick. Okay? Point 1 is 13 and 8. 13 is x, y is 8. Point 2, x is 14, y is 3. So let's use that equation up there to calculate the rate of change. So y2 minus y1. So this is y2 and this is this is y2, this is y1. And then this is x2, this is x1, right? Point 2, point 1. So let's plug in those numbers. So y2 is 3 minus 8. And then x2 is 14 minus x1, which is 13, okay? Now do the calculation. So 3 minus 8 is minus 5. You have to remember your integers, how to calculate integers. And then 14 minus 13 is 1. So we're left with minus 5. Now pick 2 other points and recalculate the rate of change. So let's do that. Let's pick these 2 points now. Let's make this point 1 and then this is point 2. So we're going to use that equation again and calculate it with these points. So y2 is still 3, y1 is 5, x2 is still 14, but x1 is now 15, okay? So now let's put in the numbers. 3 minus 5 over 14 minus 15. 3 minus 5 is negative 2. 14 minus 15 is negative 1. Negative 2 over negative 1 equals 2. So the rates of change are not the same. We've calculated a different number. So the rates of change are not the same, so this function is nonlinear. And that's how you do that problem. And don't worry about which one is y2 and which is y1, as long as it's consistent. So this could have easily been 0.1 and this been 0.2. We would still calculate a number that is not equal to the previous one. Okay? And don't worry if you don't understand that right away. You could just rewatch the video as well. Take a look at the description. I have links there to other videos of mine that are similar to this. And if you want to, you could download the ebook. In the ebook, I have this exact lesson in it. You could follow along in the ebook as you watch the video. There's a link there. It'll take you right to this video. Thank you so much for listening, and please remember to like and subscribe.